Hi, welcome to Data Structure and Algorithm series by Coding Ally. Coding Ally is a non-profit organization where we believe women and gender minorities should have a safe space and support system where they can foster their skills and career in tech. I'm Sue, your host. Today, we are solving this Leetcode problem 350, intersections of two arrays. This is the agenda for this video. First, I'm going to read the problem statement. After that, I will walk through the thought process and then implement this thought process in both JavaScript and Java using the optimized memory approach solution. So, let's read the problem. Given two integer arrays, num1 and 2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. So let's have a look at the example 1. nums1 has got all of these elements, nums2 has got 2. So visually from here, you can see that these two elements are common. They both appear in both arrays, so the output is 2. In example 2, in nums1 is 495, in nums2, 94989. So from here, we can see that these two elements are common. So the output is 49. For the explanation it's given, 94 is also accepted. Okay, these are the constraints. The constraint is nums1 length and nums2 length. They are inclusive between 1 and 1000. So there will always be elements in each of these arrays. And the values are inclusive between 0 and 1000. So in this video, I'm using the optimized solution approach. So let's read through this follow-up. What if the given array is already sorted? How would you optimize your algorithm? What if nums1 size is small compared to nums2 size? Which algorithm is better? What if elements of nums2 are stored on disk and the memory is limited such that you cannot load all the elements into the memory at once? So these are all these constraints. I have made a separate video using the hash table approach. So if you haven't watched that, you can watch the video and I'll put in the link description. So in this video, I'm going to use this optimize the solution so that we can answer this. Okay, so for this, in approach 2, we will go. The step 1 is first we are going to sort these both nums1 and nums2 array. So this is before we sort. The array are 495. So before we sort, after we sort the array, we will have nums1 and nums2 like this. So after we sort the array, what is the step 2? Step 2 is we can initialize the result array that will hold the elements that intersect both arrays. Step 3. In step 3, we are using two-pointer approach. So we will initialize the counter I and j, I for nums1, j for num2, to iterate both arrays at the same time. So in here, we start iterating both arrays at the same time, and then I is for nums1, j is for num2. Step 4. In this step, we will iterate. While we iterate through, we have to compare the value. So the value is, if the element at num1 is less than the element at num2, then we have to increment I pointer. If the elements at nums1 is greater than elements at num2, then in that case, then we will need to, because we are looking for the element that are equal, so we will need to increment the j pointer. Otherwise, then it means both elements are identical, which is in this case is 4, 4. So what we can do is we will push this because 4 are intersecting element. So we are going to push this 4 into the result array, and we will increment both pointer. So in here, in this step, we can push 4 in here. After that, we will increment both I and j pointer. So that's what we have done. So now let's keep checking. 5 and 4. 5 is greater than 4, so we need to increment j pointer. So for j previously at pointing to 4, now j will be pointing to 8. Next step, we compare 5 and 8. 5 is obviously less than 8, so in that case we need to increment the I pointer. We will increment I pointer. After incrementing I pointer is at the end, so we compare 9 is greater than 8. So we need to increment j pointer. After increment j pointer, we check 9 and 9. These two values are exactly the same. So they are the intersecting element, and we will add that into the result. We will add this into the result, and they are at the end of this both nums1 and nums2 array, so we will come up from the while loop. So now I'm going to summarize what I went through in terms of steps. Step 1, we will sort the nums1 and nums2 array. Step 2, we will initialize the result array, which is going to hold the elements that intersect in both arrays. Step 3, in this step to loop through both nums1 and nums2, we are using two-pointer approach. For that, we will need the counter, and we will initialize the pointer as I and j. Step 4, in this step, we are iterating through both num1 and 2, and we are going to compare. When we compare the value nums1 and 2, if num1's value is less, then we will increment the I pointer. If nums1 value is greater, then we will increment the j pointer. Else then means the value are exactly the same. So that particular element is the intersecting element. So we are going to push the element into the array, and we will increment both I and j pointer. So before I dive into the JavaScript solution, first I want to briefly go through these two methods which we are going to use in the solution. So in JavaScript, sort, items are sorted as string by default. So to sort the numerical elements value, we need to pass a function as an argument of array.sort. So this is how JavaScript array.sort work for number. So a minus b, we are comparing the two values. If a minus b is less than 0, then a is less than b, so a will be sorted to the left of b. If it is greater than b, then a will be sorted to the right of b. If they are equal, then they are the same. So in the JavaScript, I'm going to use this sort method, and it is the ES6 syntax function expression. So this sort is going to sort the array in ascending order. Next method I'm going to use is push. In JavaScript, the push method push the element to the end of the array. So let's have a look at the code for JavaScript. So in here, step 1, we are sorting nums1 and nums2 array. As I have explained earlier, this is sorting the array in ascending order. This is the JavaScript ES6 syntax function expression, sort. So after we sort, we will initialize the result that will hold the elements that intersect in both nums1 and nums2. Step 3. This is in this approach, we are using two-pointer approach. So we need two-pointer I and j and initialize at 0. Step 4. In this step, we need to iterate through num1 and num2. While we're iterating through, we will compare the value. If element at nums1 is less than nums2, then we will increment I pointer. If it is greater, we will need to increment j pointer. Else mean they are exactly the same, so we find the intersecting element, we will push it into the result array, and we will increment both pointer. by the end of this while loop, we will have all the elements that have the intersected array pushed into the result, and we can simply return the result array. Let's have a look at time and space complexity. Time. In terms of time, with this approach, we are sorting both nums1 and nums2. For this sort, internal implementation is O of n log n. It is a time, n log n time, runtime cost. And in this loop, the second chunk is this while loop. For this block of code, we are iterating through every single element in both nums1 and in worst case, it will be every single element in both nums1 and 2. And so for that, the time complexity is O of n. In terms of space, in here, we didn't use any additional data structure, so the space complexity is constant O of 1. So let's have a look at Java. So for Java, I'm using the array list. So in Java, we don't know how many elements that will be intersected while going through this, so we need the resizable, dynamically resizable array. For that, we are using the ArrayList class. So now, exactly the same as JavaScript, we are sorting the array. In here, we just simply pass in the nums1 and nums2 array. So first step, sort. Second step, we will initialize the result, dynamically resizable array list. Step 3 is two-pointer, ing, initialize them. Step 4, this code is exactly the same as the JavaScript, so I'm not going to go through that in detail. Step 5, not step 5, but it's an extra step in Java. In Java, the return type is return type is int array. So we need to return that. But currently what we've got is the dynamically resizable array list. It is not a primitive integer array. So we need to convert that. So this step is converting the array list into the integer array. So first we initialize the final result array, and we know the size. We know the size of the array from result. And we will iterate through this result array, and then we are going to put that element into the final result, and then we will return the final result. So let's discuss time and space complexity. Because we are sorting this array, so because of sort, time is O of n log n. In here, for this while loop block, it is O of n in worst case. For the space complexity, we didn't use any additional data structure, so O of 1. So overall, time is O of n log n, space is constant. Thank you for watching. Please make sure to subscribe and press the like button if you find this video helpful. Join our weekly Wednesday data structure and algorithm, where we organize peer-to-peer coding interview. You can find advanced detail on our Facebook page. Thank you.